So hi everybody, even you can. Hi. And so my name is Idit, and I'm from EMC or Dell EMC. I did changing them. So I want to tell you about a project that we did. But in order to understand this project, I will go and explain you a little bit about Unikernel, what it is, the market, and so on, and explain what we did there. Okay. So this is the stuff the way we know it today, right? When you're running everything that you want to run a container. Usually you're running on even if you're using Kubernetes or Docker Swarm or whatever you're running. Usually what you have is a hardware, because everything eventually running on hardware. Then you have some hypervisor. Usually that's what people are running. Not that you don't. It's not a must, but most of the people does running it, which basically means that you're running an hypervisor operating system with the drivers. And then you're putting a guest OS, right? Because eventually that's where you're going to run. And in the guest OS, you have, again, drivers. And you also have the kernel itself, that its job is basically to protect, schedule, and manage the memory and so on. And then what you do is you have the OS user processes. And that feature job is basically to protect, to separate between your processes that are running on your machine. And then there is the Docker, the runtime that you're putting on top of it, which is basically kind of doing the same thing, right? Separating as well. Then you're putting inside the Docker the shell libraries, the language runtime, the application. That's what you're running every time that you're trying to run a very simple microservices application. And there's quite a lot of redundancy, right, if you're looking at it. Because in terms of isolation, for instance, you have it on the level of the hardware, which is a separate, actually physical separation. Then you have it on the hypervisor between the VM. Then you have it on the processes itself. Then you have it on the Docker itself, and then you have it on the application, right? So you have quite a lot of separation that basically, because the stack is so big, you need to cut and slide until you're getting these microservices. And when you're looking at it again, just bear in mind that when we really want to run, we want a single application with a single user on a single server. And this is the key. That's all we want to do. And the kernel itself is kind of complex. And if we're looking at why it's so complex, it's because its main job is to protect, and what it's protecting. So if I'm running on this machine, and Ashish here is running his own process on the same machine, we need to make sure that we're not hurting each other, that my application is not killing his memory, that he is not killing my processes, and that we have a separation. And that's a hard job to do, and this is what the kernel in charge of. And that makes a lot of sense on the 5060. And why is that? Because back then on the 5060, we had a mainframe, and that was very expensive. You cannot afford yourself buy a mainframe and give people, run only one application on it, because it was expensive. So what did we do? We needed to share, right? We did time sharing, right? I run my application on this time, you will run this application on this time, and to be very useful, we can run it together, but we need to protect, right? Besides that, if you're looking at a lot of other stuff that today in the kernel, you will discover that, for instance, in this Mac, I have a driver of a floppy. Everybody knows the machine, they're running the floppy driver. No one is using floppy. You still have this driver and this bit and byte running on the machine. Same thing with USB. You're running on Amazon, you can't even get to the machine, you still have the driver of the USB. So again, a lot of unnecessary data running on your machine, processes that are running, and making your system very complicated for no really good reason. If you look, the same thing, we can go on and on, but basically if you're looking at the update model, it's the same thing. If you're doing today YAM update or get up, you're getting a lot of junk to your machine. You don't know what it is. Some of them you don't even need, but you're still getting them. In terms of security, so because there is so much junk in your machine, the surface of attack is very big. So in terms of security, thank you, Ashish. In terms of security, so the surface of attack is huge, right? Because I just explained that there's quite a lot of stuff that you don't need there. You just heard probably about the telnet service that caused the last DDoS attack. That was a good example, right? They didn't even know that it's there, right? They just installed Linux, put a very nice. It's very limited. A lot of junk you have in the machine. You need to be very careful. In terms of sharing, we're sharing quite a lot of stuff in the microservices architecture. So we're sharing the kernel, we're sharing the memory, we're sharing the file system and the hardware. And the only thing that basically protects us is a feature of the OS we call C group. So it's working, right? But it's like take a big house and basically put a lock, right, on the door. You still have windows and door, and it's dangerous. Versus take a room which is room without door and window. That's kind of more the Unikernel approach. So we'll go for it in a second. So again, just to show you how complicated this stuff, this is the Linux kernel language that you need to know in order to support, right? To maintain. That's kind of crazy, right? I mean, it's going on, and there's not a lot of people who understand what's really going on in the kernel, because it's very complicated. If you're looking at line of code, small application, this is my definition. Small application is usually 10K lines of code. If you're looking at medium to large application, it's around 100 line of code. And if you're looking at really huge application, it's 1 million lines of code. This is like a team sitting and actually maintaining it. And this is only the Linux kernel. It's only the kernel itself. It's not a operating system. 22 million lines of code. And if you're looking at the Debian distro, for instance, Ubuntu, if someone running, it's 419 million lines of code. So this is like, it's very hard to reason about, tons of bugs, right? More code, more bugs. Okay, so I just describe you in a very quick way why there is so much inefficient of what we're doing today. And the real question is, how did we get there? And the answer is quite simple. It's evolution, right? We started with the mainframe, we went all the way to the Android and the Internet of Things devices, and we just, Linux were there all the time. It's always been there to support us. What can Linux run on? Everything, right? You're running it on Raspberry Pi, running whatever you want, right? What can run on Linux? Everything. I can take the last distro of the last Debian distro, basically run it on a Pentium 10 years ago, and it will work, right? Out of the box. I don't need to change anything. Which basically means that we as a community make a decision, and the decision was that it's much more important to us to support compatibility versus efficiency, right? So we want to be able to run everywhere and make a multi-purpose OS. More important to us to actually make it something that will be very efficient to what we need. And we make it works, right? But it's not really the right architecture for what we're running today, because stuff changed, right? Right now we're running microservices, and we need to be very efficient and scalable and so on. And I hope that also afterward we will make it fast. So, okay, so that's all good. The question is how, right? What can we do to make it better? Can we rewrite the kernel and the operating system? Should we run one from scratch? It probably will be a lot of work, right? Or maybe not. And this is a quote of Linus, the guy who wrote the UNIX kernel. And basically, this is a quote that it was an argument between microkernel and a monolithic kernel back in the day. And what I want you to take from it is the last quote, which is basically what he said, is that it took him a year to write the Linux kernel without knowing anything before, which means that it's not that complicated. And he believed that most of the people can do that. So that's exactly what the Unikernel ecosystem did. They basically rewrote a very specific a very specific operating system for what we need today. So let's understand how it works. So this is the way it's working today. Today you have the kernel. You're always running the kernel on every machine that you have, and you're running all the OS libraries. No matter which application you run, you're always going to have all those libraries and all the kernel. What Unikernel approach saying is that let's take only what the application needs. So it's looking at the application. When it compiles, you know exactly what it's using. It will take only what it's using and nothing else. So for instance, if your application doesn't need volume, you're not going to have the driver for the volume. You're not going to have any of the libraries that are related to this, because it's just not relevant. The application is not even using it. So it will look something like that, right? So now we're stripping it down dramatically, right? It's not big anymore, because if part of the kernel shouldn't be there, it's not going to be there. So that's a little bit more technical. So like again, what does it mean? We needed to make some decision here. So the idea is that we're running only one process. This is a real microservices architecture, right? Only one process. If we're running one process, a lot of the stuff we don't need anymore. For instance, protection. If I'm the only person who's running on the machine, the admin, and I'm only running one application, do I really need rings Do I really need to protect and differentiate between a kernel mode to a user mode? Why do I care? Everything can run on kernel mode. And the reason is because, again, I don't need to protect. The reason I'm always protecting you is that what will happen if I'm running my process, someone else is running his process, and then someone here try to take the machine down, right? What will happen, I want to make sure that even if we're trying to do that, you will not be able to hurt my process, right? So even if we will try to hurt the machine, my process will stay up and the machine will stay up. And that's why you have the kernel. That's why you have the multi-space, memory space, and so on. Again, all of this is to protect. Again, if I'm the only one who's running and my process is the only one we're running, who am I protecting from? And the answer is no, I don't need that. So now if I don't need it, it's very interesting. Now I can run on kernel mode, right? Because if something will happen to my machine will die, then my application will die, but who cares? I mean, I need to make sure that it will work, but I didn't hurt anybody else, right? And that's basically what the operating system try to do. And the other thing is that, again, there is no context switching. There is no, memory, virtual memory space and so on, and that's taking a lot of it's basically taking your performance down because every time you need to set. Is that this one or this one? It's taking a lot of time you don't need it. So again, we're taking everything that we don't need down, all the performance aggregation, and basically making a very, very efficient process running very, very good. So that's basically what it is. Single process, so you cannot fork. You can run multi-thread, but you cannot fork, and that's important. So if you want to take a monolithic application that forking, it's just not going to work for you, right? But in the microservices architecture, it's actually making very, very sense. Okay, thank you, Unikernel creation. So how do you do that? Very, very simple, actually. What you need to take is you take in your binary, and you need to take your config, and you need to take your dependency. You need to take the language runtime for the language that your application is written in, and you need the drivers. You're putting all of this inside some magic tools, which I will describe soon, and then the end result for it is a unikernel. So what is a unikernel? It's basically a bootable image. And it's very, very small, because as I said, it's not containing much. So now you can go and actually launch in a bare metal. But it doesn't really make sense to take a big server and run 56 meg application, right? So usually you're running on an hypervisor. And it's good because hypervisor is giving you a physical isolation, right? This is the advantage. What we take right now a Linux distro and one container on it. Guess what? It's not really protected. And the reason is A, because you're sharing a lot of stuff, but second of all, the separation is on a software level. But when you're taking it an hypervisor, the beauty of it is that it's doing a physical isolation. The chip itself is isolated, which is kind of like very, very unique and very, very secure. So again, you're getting the performance of container, because I will talk about it in a second, but it's very small, so it's booting very fast and so on, but you're getting the security and the isolation of VM. Okay, so again, you probably will run it on the hypervisor if you're running on the cloud. And what you discover is a regular VM, right? I mean, it has its own network stack, and it's a VM for everything. And you can actually also apply the regular VM that you know, like for instance, vMotion will work, right? I mean, this is a VM for everything. So what did we do? Our stack changed right now. Instead of running all of this, right? Right now you're just running basically the hypervisor and putting a VM on it. And the VM is much smaller, and you will put much more VM on it, but that's it. Again, we just took what we don't need, we reduce it. So now we're talking about much less line of code, which means less bug, much easier to reason about, which is very, very useful. So again, let's summarize the advantage of Unikernel. There's no other user. There's no multi-user support. You can put it on your application. It's not going to be on the OS level. There's no permission check, which means that 100% of your utilization is going to your actual application. There's no overhead. The isolation is only on the virtual hardware, and you share only hardware. That's why you share it, right? The minimum, in terms of size, the minimum size of VM that I'm taking today, I don't know, it's 1 gig at least, right? When we're talking about Unikernel, the size of the Unikernel is the size of your application. What we're putting on top of it, it's like so minimalistic that it's basically the size of your application. In terms of booting time, it's quicker than, it's crazy, right? You need to boot 2,000 lines. It's nothing to boot 2,000 lines. So it's much faster than everything that we can find, including container, by the way. And the last thing is the surface of attack is tiny, but it's also custom. which means for every application, the libraries will be different, which means that even if I'm as a hacker, manage somehow to find a way to export it this machine, it's not going to work on the other one because everything looks different there. So basically, it's very, very custom. Okay, so I just want you to be knowledgeable about what's happening in the Unikernel today. So there is two types of Unikernel approach today. There is one with forward compatibility. That means that you will need to rewrite your application from scratch, which is a problem. And usually it's a language specific. So for instance, you all probably heard about the fact that Docker bought a company called Unikernel System. Unikernel System has a Unikernel called Mirage OS. Mirage OS is written in OCaml, and the only language that it can run is OCaml, which means you can only run OCaml. And I will argue that not a lot of people is running OCaml. So that's that, right? If you're looking at Include OS, it's a C++. It's a very, very good Unikernel in C++. And you literally need to write Include OS because they're all their own OS libraries. So just need to understand what that means. Besides this, there is the POSIX compliance one. And POSIX compliance means that you can run whatever you want, right? Because POSIX compliance is basically the API of the operating system, which basically means that you can rerun in Go, C++, Ruby, Java, Python, just name it, we can run, right? So that's this is a benchmark just because people are asking about performance, so I wanted you to see here. OSV, so OSV is a Unikernel that's been written by a company called Claudius in Israel. And they did Unikernel a long, long time ago, but they really, really freaked out when they discovered that Docker exists. So what did they do? They decided to pivot. And how they pivot? They pivoted basically, they took Cassandra and they rewrote it to run on the operating system, the Unikernel. And it's an interesting approach, and they call it ScalaDB. And what I want you to see is the performance, because I think this is quite unique. So they basically got it 10 times better performance on a Cassandra. So again, if you have something that you really need, like performable application, probably that will be the way to go. I don't know how we have time because it's still late, but I mean, this is two examples of Unikernel that's out there, and it's kind of like a cool project, so I wanted to show you that. But we'll show it really quick. So the first one is this one, which is actually the Mirage guys put it there. They basically created a game, and they said, look, we're telling you that Unikernel is very security, but we'll let you try to prove us otherwise. So we're going to put the Unikernel out there. We call it Pinata. We will put something inside and try to get it. And no one did. And it's like 2 years. I mean, you can go there. You're welcome to try. Please don't tell me that it's freeze again. Okay. Okay, we're not going to go there. Hopefully, my computer will react. Come on. Sheesh. It's ridiculous. Yeah, in a second we'll have a new computer.
Can you?
1 second. Okay, it's fine. Just couldn't say. Okay, so we will not show you this game because for some reason it has any issues. But basically that's one of them, and the second one is just showing how quick stuff is booting. So they're showing you that this is the amount of time that it's taking to boot machine in AWS. This is the amount of time that it's taking to click a button on Android. And usually it's 0.02 seconds ago you ask for the Unikernel and it's up. Right? They just want to show you. So, but I will share this slide. You can go and look at it yourself. So what did we do? Just told you a lot about Unikernel and how awesome it is. And when I looked at it, and my team and Shisha, we looked at it and we said, why people are not using it? This is amazing. I mean, this is really, really good. And what we came with is it's because, for my opinion, is that it's hard. I mean, I'm a developer. I just wrote my website. I don't want to understand how to compile a driver. It's too hard. So I need someone to do that for me. And this is exactly the problem that Docker had before, that container has before Docker make it easy to use, right? Few companies were using container. Now everybody using container because it's very, very easy to use. So that's what is UNIK is all about. What we wanted is basically that you will take your, you will take your application. You will have the ability to run it in a container, but the same application you can run in Unikernel. And then it's all a matter of use cases. We need more performance. I'm running on Internet of Things. It needed more security, and so on. And that's exactly all the point of UNIK. So it's a command line tool. I will show a demo in a second. Very, very simple tool. How you working with it, and I will show a demo, but basically it's very simple. You're doing UNIK build. You're giving me the path where your application is. You tell me which type of Unikernel you want to compile to, because we didn't want to make a decision. We wanted you to choose. So we basically support most of them outside. And for good reason, because each of them are special. Language, which language your code is written in, right? Because we need the language one. And then provider name, whether you want to run it on, because we need to compile drivers, right? You want to run on AWS, I will put the Zen drivers. You want to run it on VirtualBox, it's different, right? Virtual I/O, it depends when you run. And the last thing is give me a name to the image that you created. So now you created an image, right? And basically now you can actually run it. Now, Unikernel, it's a real immutable infrastructure, because if I want right now, I cannot go and modify to it. There is no services that are not needed like SSH, which mean to me that in the end of the day, if there is a problem, or if I want to operate it, I just need to build a new one, right? It's a real immutable infrastructure. And then what I will do is I will run it. So we're doing a little bit more than Docker, right? Because we're already talking kind of like to the provider and running it for you. Okay, so we're running it, you're giving us the instance name. We know where you're running already because you told us which provider before. We're running it for you. So again, for my opinion, this is the most important slide, is how we build UNIK. And I think this is what makes it very, very powerful. So we were very, very inspired by the Kubernetes architecture, which means that everything is very, very interface-oriented and kind of like separated nicely. We have three main entities. The first one is the Unikernel type. As I said, I wanted you to the ability to support all of it. So right now we're supporting OSV, mainly for Java. It's a very good. They did a lot of nice work with Java. Include OS. Actually, that's a pull request from Include OS. A ramp run, which is POSIX compliant, so you can run almost everything in Mirage OS. We also, I will talk about it later, but we're also adding, we already added support for Solo 5, and I will talk about it in a second because I'm not sure that you know what it is, but I will explain it in a second. The second thing is cloud provider, right? Where do you want to run? So right now we're supporting OpenStack, we're supporting VirtualBox if you want to run locally, we're supporting AWS, KVM, QEMU for debugging is very good. VirtuStream, which is an EMC cloud, so we had to, and a vCenter and Photon. And I'm going to talk in KubeCon next week, and I'm going to make an announcement, so just can tell you before, is that we are already supporting a Google Cloud as well, so we can run it as well. And the last thing is that we of course supported Intel, but we understood that there is a big use case for Internet of Things. And the reason it's very, very light, it's very, very secure, and it's very, very performant, right? The performance is killer. This is three features that it will be very useful for the Internet of Things. So we wanted to add support for ARM, and that's what we did. So that's one thing. The second thing is that we understand that you want to share your Unikernel, because if I already built it, so I don't want, maybe Ashish want to run it on his machine, and also, not everybody who's building is the one who's actually running it, the operation and the development. So we just wanted to make sure that you will have a very easy way to share it, and this is UNIK app. It's not that different than Docker app whatsoever. It's different because Unikernel, there is no such a thing of file system layers, right? So it's a little bit different. But basically what you see here is that I'm basically pull a Unikernel and this, in that case, it's a Minecraft. Okay, so before we even open source it, which it is open source, we wanted to make sure that it's playing nicely with the ecosystem. So the first thing that we did, we basically teach UNIK to speak the Docker API. And the reason is because all of you have scripts, and all of you are running cluster management, and they know how to run Docker, and they know how to run they know how to talk to Docker. So we wanted you not to need to rewrite your script. So what we did, we just basically used the -h flag in Docker for remote daemon, and now you can actually target UNIK, and we will translate the API for you. So that's one thing. Second thing is that we integrated with Kubernetes. So next week I'm there, we're going to open source it, make celebration. But basically what we did today in Kubernetes, you can run Docker container or Rocket container. Now you can also run Unikernel. And that's really cool because, UNIK, it's like Docker. It means that you can spin up the Unikernel. We will not monitor it. If it's dead, it's dead. It's on you, right? So what all those cluster management bring you is the stage, right? The health, basically, which is very useful, and the fact that it's always as much as you ask, right? So basically, eventually, you're getting as much as you want. We wanted to leverage that, including the networking, and that's what we did. So basically, right now, you will be able to use to create the UNIK inside a pod. And we also, before that even, did integration with Cloud Foundry. So in Cloud Foundry, it's actually even cleaner, because what's happening in Cloud Foundry is that you can do something like build pack. So we created a build pack. And that means that you can use whatever Cloud Foundry distro you have and basically run your kernel. Let's see demo. I hope that we're good on time. If not, you know what? Do you want first? Let me first finish the presentation, and then I will show you demos, because I'm afraid we will not have time. So I'm going to, okay, let's do it. So take quick, and then I will show you them. Okay, so as I said, we understood that it's very, very important use case in the Internet of Things. So what we did, we decided to create a future instead of just talking about it. And what we did is we were the first people to actually take ROM kernel, Unikernel, and run it on Raspberry Pi. And when we started doing it, it was actually horrible, because we put the Unikernel on the Raspberry Pi and we got black screen. We couldn't even debug it. It was like black. So what you see here is this is our developer environment. What you see is that we basically took the Raspberry Pi, we attached another Raspberry Pi with GDP, and we basically debug it, and guess what? It's working. So usually in conference, but I didn't put the toaster here. So we're running this, which is basically UNIK is making us toast on stage. But I didn't put the toaster, so we're not going to see it, but it's all over the internet, so you can go and look at it. And this is interesting, because so you all probably heard about the last DDoS attack. And the question is, if those devices were running Unikernel, if that attack was actually could still happen, or it will be prevented. And I wrote a blog on it, so you can go and look at it. I mean, I really recommend you. And the answer, of course, is yes. And it's a very technical kind of like argument that explains how the malware was working, how Mirai did it, and how it will prevent it. But I mean, go read it. I will send it to you. Okay, it's supposed to be the toaster now. I will not do it. We will talk about that a little bit more, and then I will show you a demo. So, coming soon. So, that was our roadmap. The first thing is Mirage OS. We already did. The second thing is Solo 5 and UKVM. So, for that, I want to tell you about it, because I think it's quite cool. So, here's what's the idea. When I'm building a Unikernel, as I said, I'm taking the application and I'm putting all the libraries that I need, right? Building whatever I need for it. But then eventually I'm going and running it on a hypervisor. And the hypervisor always going to give me all the backend, because it doesn't know what I need, right? So for instance, if my application doesn't need storage, it's still going to give me the backend of the storage. And that's a little bit dangerous, because for instance, one of the exposes was that someone was somehow managed to get to a machine and mimicking the floppy, basically the floppy driver and kill the hypervisor, right? Because the backend was there. So basically, if you don't need it, why do we need all of those backend? And that's exactly what UKVM is. So it's actually a project from IBM. They took basically KVM, and when you're building your Unikernel, you're also building your hypervisor, and you can run it on Linux. So go and look at it. But I mean, the cool thing is that UNIX is already supporting it, because as I said, it's very complicated to do all the stuff that we're doing, so we just automate it. So basically, you can right now run with UNIK on UKVM on your Linux. So go try that. Support. So we actually have that, but I mean, it's illegal. It will take us a while to open source it. So stay tuned. .NET support. So this is interesting, right? I mean, let's look right now about the .NET support. Right now, Microsoft did us a very good favor. Basically, what they did, they took the .NET and they make it run on NetBSD. NetBSD is basically the bone of the Unikernel RAM. and the way it works is like this. If you're looking at the Linux kernel, it's very tight together. It's a mess. It's very hard to go and kind of like pick and choose what you want. So the guys from NetBSD, they basically did a rewrite for this operating system. And what they did, they basically created a component. So now it's interesting, right? They call it I forgot the name, NEOS. So then what you can actually pick and choose what you want, right? It's very, very interesting. So now you can choose whatever you want and create the kernel. But if it's working on the same driver that the NetBSD is working, would mean that if it's working on NetBSD, it can work also on Unikernel. And now you can actually take a .NET and run it on Unikernel and not even pay license for Microsoft at all, right? Oh, no one Microsoft. No, but that's the idea. So we did it. We will open source it. I think it's cool. Serverless. So today, when you're running serverless, when AWS is doing it, and I think most of them, I think that there was a IBM talk here, usually they're reusing container. With Unikernel, you don't need to, right? Because the boot time is so quick that basically you will not need it, and it's more secure. So basically what will be very interesting, and there's quite a lot of work that's been done, is basically to take a project like OpenWist, or we had our own internal implementation, and basically create a backend of not only container, but also Unikernel, and then kill it, because we don't need to reuse them. There's no point. NFV, so actually there's quite a lot of interesting work in the NFV. So Mirandis reached out to us, Nokia is reaching out. There's quite a lot of companies who are reaching out to us, and the reason is because in the NFV there is a lot of work of actually, you need a DHCP server. What if I'm not going to actually use it all the time? I'm just going to spin it as needed. So I will did it. It will translate to whatever it needs, kill it, and so on. So again, there's quite a lot of article there, and it's open source. So go and look at it. It's very cool. And we really, really into the community, because you will be surprised, but all the work that I just described basically been done by me and 2 more people. That's all the team. And we build it very smart, so we are very, very quick, because this project is very new, but we need help. And the OpenStack, for instance, support came from a project from Michelangelo from in EU, and IncludeOS added support for their for their Unikernel. So we want you to help us, guys. And what we did for that, we created a Slack channel. We constantly there. We answering questions. We helping everybody. I mean, really, like, just come and ask questions. We will help you make it done. We have a unique Twitter account, so you can. So every announcement, I'm making announcement. I'm the marketing person also. Basically, I'm going to say we're supporting this and we're supporting that. And also, as I said, and of course on our GitHub, just come. It's open source. Just help. This is the team. Just wanted to give them kudos. So Scott and Yuval, amazing engineers, and I'm the CTO. And that's it. So now let's see demo, because I don't know, I'm probably over time. So if you don't want to see, we can skip it, but I think it will be cool. So let's SSH to AWS machine that I prepared before. Nothing is working today, so let's...
SSH is blocked on the wireless.
Oh, no, are you serious? No, but I just run it there, so unless I'm not running on SIM.
Okay, it was blocked earlier.
Really? What is the network? Where is the network? I can't see the network. It should work. Maybe I don't have network. 1 second, I'm taking it out because otherwise I cannot see the network. Let me see. I'm running on the wrong network, that's why not. Here is the open and it will work. That's why also, by the way, it's... Okay, so now it should work. Back. Needed to pray before that, I guess. Okay. Now also everything works there. Okay, so we're going to SSH right now. It's stuck. Oh, the machine's stuck. It's painful, guys. Please work. If not, I will show you locally after. I don't know. It's not really playing nice when you can do. And that I cannot even do on your machine. What are we going to do? Shouldn't have your demo when there is that.
Excuse me?
Yeah. Is there any question for the meantime? But not
Yes, you were mentioning using this with Kubernetes. Is that, I noticed there was a project where they're working on their own hypervisor. Is the mindset that they would move into that space and act as a...
Not exactly. I mean, I know what you're talking about. It's a... they basically try to do container physical isolation with hypervisors. So they're building their own. I think that, first of all, as far as I know, and I need to check more, but they were building their own cloud because, of course, if you're running you're very, very limited, right? You cannot run on AWS. You cannot run whatever you want. So they both, if I remember correctly, you're talking about Hyper something. I don't remember the name.
Yeah, I don't remember the name, but I know I saw it.
Yeah, so could be. Hyper something. But I mean, they did an integration with the Kubernetes, but it's very limited. It's only on their cloud. You need to go there, run it on their machine, and basically it's container, just running on an hypervisor, and you try basically to create a physical isolation for the container. But it's not UNIK. It's not the same thing. And I think maybe my machine is up again. Yes. And you said 10 minutes, so I need to know. Okay, please. Any other questions? Yeah,
How do you get configuration or environment variables into it?
So we did some magic here, actually. So when we're booting the Unikernel, we're using something called grub. Grub is basically a bootloader. So we say, well, we're using this one, so we can actually also inject. So basically, we're injecting an environment variable to it. So
From
we're getting that.
a YAML file or something, or
So you put in a key value, yeah, exactly.
Key value file?
Yeah, And so that's that. And also, another cool thing is that we also kind of like giving the logs back. And if my machine will wake up. I can show you, but basically the core of it is we also streaming back the logs. So if we're streaming back the logs, we can actually, you can monitor for real. So like you can do instance logs and see everything that
so the
runs.
hypervisor is the one that gets the logs?
No, the Unikernel itself. And the coolest thing is that, I heard before that people say that Unikernel are not ready to production because you cannot run Dtrust, stuff like this. But actually, you can debug it much better because you're getting all the stuff. Think about it. You're getting you can see in the logs how the application is kind of like booting out. So you can see all the operating system or whatever there is, and then the application itself. So you can see everything. And we also attach debugger in QEMU, so we can do it in all of them. It's just, again, 2 people, we're doing our best. But basically, you can attach debugger to it and do a lot of crazy stuff, like step into the application.
But to get the logs, you have to have a storage piece in there, right? So you have to have that compiled.
No, we're streaming it.
Oh, you're streaming it
We're
out?
streaming it to UNIX.
Okay.
So UNIX is getting it, and UNIX.
I see.
Make sense? Yeah.
So what's more efficient if I have like 100 applications, right? Would I run it in the Unikernel environment or a Docker environment? Because
See?
it's a shared file system in Docker, right?
So it's a good question, right? I mean, it depends what your application is doing. It depends, I mean, in terms of what? In terms of money? I mean, it's a question, in terms of performance, you will get a better performance. Again, it depends what your application is doing. If your application is a regular monolithic application, you can't even run it in Unikernel. If it's a real microservices architecture, you probably can run it. It depends, in terms of performance, it will be very, very dramatically better if you're doing a lot of IO and stuff, right? But if your application is not doing much, not doing any computation or something, it's probably you will not see a huge difference. So again, it depends. If your application does not really care about security, go run it in Docker. It's easy, right? It's already working. It's done. Unikernel, again, for more security, it's more specific. It's more. The stack is small. Everything is more to the purpose of what you really need.
But you're saying the IO's throughputs will be better in Unikernel because you're embedding all those layers?
There's no layers,
Yeah.
right? Right.
What was the workload, the example you threw up that was sort of 200 times or 20 times better?
This is a Unikernel called Asphalt, but they have a website. I mean, my computer is killing me today. If it will work, I can show you. So I will show you I will tell you what is the demo that I plan to show you. Maybe it will work because it's waking up again. But basically, what I wanted to show you is, first of all, I wanted to run in Minecraft on Unikernel. Hopefully, I will be able to do that. Very, very simple one. What I wanted to show you about it is that I can also see the logs. Very cool. So I can actually go after it and do it's basically streaming it to a port. Let's see if it's work. So scale it. So I plan to show you that. Then what I wanted to show you is the integration with Cloud Foundry. I will save the Kubernetes integration to KubeCon, but basically the idea, and that's what I will show in KubeCon, is the idea of I'm creating an application. It's very, very quick. Then I'm going to scale it to 4. I'm going to kill 1 from the UNIK, and then I will show you how it's coming back. Right, that's simple. So I just wanted to show you that it's basically leveraging the thing. And the last thing that I wanted to show you is another website with Node.js, just to give you an example how easy it is to work. And I don't know, my computer is dead. It's no power one.
Can I ask you a quick question? You said the I/O is more efficient with Unikernels, right? I mean, why would you say that? Because you have a hypervisor layer. In the Docker container, you don't have a hypervisor layer.
How many?
Your I/O would be much more efficient.
So hypervisor today, the I/O, it's almost like there's almost no overhead, right? They did, at least on the, it depends when hypervisor you're running. In vSphere, they did quite a lot of magical stuff where it's almost the same. Like it is giving a little bit, but it's almost the same. But what I will argue is that unfortunately most of the people are not running Docker container on a regular bare metal machine. There is some, but not most of them. And most of them actually running it like when you're running on Ubuntu. And the Ubuntu is a guest OS that's running usually on an hypervisor. So you're paying actually much more here. So again, it's all measure it, but it will be cool to do a bench. But you can see it. For instance, the guys from Claudius, they did it. It's like 10 times better. There's no question about it. You can see that. So it's interesting. More question? I don't know. It's ridiculous. It's the first conference that I'm not giving demo, but that's because nothing working. Anyway, let's see. Switch the network. We will try again to connect it. If it's not connected, we screw it. Let's see. So this is this. Try to connect it. So I'm SSH to it, and that works. So now we'll try to see if you can see it. And if it looks at the computer, look at the computer. Okay. So yes, we are on the machine. So now what we're going to do is UNIK, and this is a very simple command line of UNIK. We're supporting, by the way, a lot of the cool thing about it is that it's VM. So you will discover that a lot of the problem that we guys have, or we had, I'm also part of the community of the container, right? And the problem that we had with storage, persistent, for instance, so network is not existing in UNIK. Because you know what? It's a regular VM. There's no problem there. So we're supporting that as well, by the way, floating storage and all of this. It's already come out of the box. So what we're going to do next is we're going to do unique images. And that's basically what I built before. So what you see is I have 3 images running here on AWS. It's basically in AMI. It's an AMI. So when we're building it on AWS, we're creating an AMI. When we're building it on, I don't know, vCenter, it's not an AMI, it's just a VMDK. But that's what you see. And now what we're going to do is we're going to run one of them. So let's just, for instance, run, let's see which one, over here. So you see that I have right now a unique run instance name. I put Idit, and what I'm doing is using the Node.js demo. So we're going to run it, and you will see that for the unique PS, so it's running, and it gave me an IP. I can take it. It's still pending, so hopefully. So by the way, it's pending because it's running on AWS, and AWS is taking time to actually build. It's not our fault. Like if we're running on local, it will be much faster. So let's just go and see what I ran, and what you will see is that. So this is a Node.js, so it will be 88, and hopefully it will work in a sec. Still pending, so it's a sec.
Does this literally pull bits from the like say the Unix or Linux kernel and package it into a combiner?
No, so this is cool. On AWS, on AWS, we're actually running it on hypervisor of the Zen of them. So it's not that we're creating something and then running on it. We're actually running it, we're creating an instance and running on their Zen, which means that there's no overhead, right? We're using their drivers. So this is a website, right? You see on AWS running, kind of like a very simple one. And you will be surprised that this is 56 meg, right? Now, we'll say one more thing about it. It actually does not make sense to run on AWS. We're doing it because that's the infrastructure that I have. But basically, AWS, the minimum size of the storage there is 1 gig. I'm not using storage here even. I still need to pay for it. the smallest size that they have, I just don't need what they need, right? I have nothing, it's nothing, it's 56 meg. Still need to pay for it. So it would be much more sense if they will change their model, or if you will run it, on your infrastructure. But think about it, if you're taking your vCenter that you're running right now and you're basically creating quite a lot of small VM instead, think about all the data for the drivers and the operating system and all the mess that you're running there, just done. Think about how much you're actually saving. So this is one website. What we will do next, let's run, you want Minecraft or you want to see the demo of that's the Minecraft. So again, and by the way, to delete it, it's as easy as UNIK, delete, instance, minus, instance, probably not equal this, right? For the name, both of them will work, minus, force, because it's running. Done, I don't have this anymore. So now, let's go and do the same thing with the Minecraft. So I'm coming here and I'm doing UNIK. I think I have it. That will not need to do that.
So, no, is this gonna work? No, it's not gonna work. It's not gonna work.
I left
It's
the one
not
mic in the other room. But I found it.
Okay, so what we're doing here is just again, the name that I read. So basically the image manager is Minecraft. Let's see if it's not right. Okay, yeah, so I basically just ran the Unikernel of the Minecraft. Yes, to get the IP. So we have the IP. What we need right now is to actually start the Minecraft, and because it's crashed, so Minecraft crashed too. So we're going to basically just give the name of the server. We'll see running in a second.
Test. Hello.
Okay. So I'm going to add the server. And the IP address is 54, 10, 236, 2. Come on. Now we're going to run it. And this is Minecraft running on the Unikernel, right?
Now migrate it. Sorry. Because that's the demo that I like.
Right. I'm not playing. Okay, so that's that. And the cool thing about that is that right now, if we will go to this IP address that we just put here, and we take a regular browser, or we can also do it from UNIX, and you're going to do this, and we're going to port this and do logs, you will discover that we get all the logs. You see the operating system is actually booting up, and then you will see that I'm surviving or whatever I'm doing in Minecraft, and I left the game and I don't know how to play, but you get it, right? So that's cool thing. The last thing you want, so the last thing that I wanted to show you is the last demo if we have. I think Andrew soon will kick me out, but quick, just that you will get how simple it is. I have a Cloud Foundry running here. I know most of you are not using it, but still it's cool. What I can do right now is just I have an application here. It's a Spring application. And then what I'm going to do is as simple as push. So CF push. And basically what we'll do right now is we'll build my Unikernel. We'll run one, then we will scale it, then we will go to UNIK, we will kill one, and we show how UNIK is, basically it's going back, because Cloud Foundry is bringing it back, if we have time, because everybody here is scared. So that's the demo that I have. Any question? I mean, any thought? Someone like it, don't like it, what's going on?
Is Unikernel supporting Cloud Foundry in the current release of Cloud Foundry?
So I told you, Cloud Foundry is actually very cool. Right now, I'm running it with a regular pivotal web service, which means that it's whatever distro you're putting, this is a build pack, so it will support for everything. The old one, the new one, and if we will go to pivotal web services, you will see that it's basically running there. It's not even my pivotal distro. I just took whatever they're putting online. So yeah, so it will take a second, but basically then it will do it, then it will scan, you get the point, right? And it will work, trust me. So, more question? As I said, Kubernetes is actually, to be fair, it's already open source, we just didn't announce it. But you really, really, for my opinion, need to go to my team repository. We have another cool project there called RX, which you should check out. And what you can see here is that, going here, this is a horrible resolution, but there is UNIK, there is the RX stuff that we're doing. This is the Kubernetes one, so we fork, so you can go and look at it. This is the Cloud Foundry one. This is the app itself. You can go and look at it, and there's other private stuff we didn't open source yet. But go look at it and help us make it better, because there is quite a lot. I mean, I don't know if you noticed, but this is a new project, and as you see, there's people digging it, there's community life. I mean, this is going very well. So go help us. It will be huge one day. So okay, cool.